Structuring the third event risk, weather-related delays. Now we consider a third type of event risk. We call this type of risk a multiple frequency single type of event. In other words, an event may occur or not a number of times during a certain time period or project in this case. Remember that this risk is related to weather conditions. During the lifetime of the project, it is estimated that on average, either 2 or 3 weather-related delays may occur for this project. We will then use 2.5 as the average number of events that might happen on such a project. To count the frequency or number of events per project, we will use a Poisson distribution. A Poisson distribution always returns only integer values, with a mean and variance equal to its only parameter, lambda. It is usually used to describe, for example, number of individual events that occur in an interval of time when the events are occurring at a constant rate. The number of customers arriving in a queue, the number of accidents on a road, or the number of imperfections per meter of an item being manufactured, the number of items in a batch of random size, the number of items needed from an inventory, the number of periods, either months or days, a device is out of service, or the number of claims in an insurance policy. In this case, we are using it to stochastically count the number of weather-related delays that the project might have. As in the previous case, we also require a convoluted function implemented through the risk compound function in @risk. This is due to the fact that each one of the eventual weather-related delays that might happen should each have a different severity magnitude. If we would simply multiply frequency times severity, then we would be assuming that at the iteration level, when more than 2 events happen, all of them will have the same severity. This is a simplified assumption that creates imprecisions on the length of the tails of the simulated distribution. To avoid this, we use the compound function. 53. On cell K18, click on the Define Distribution button. On this special tab, select the compound distribution. 54. By selecting on compound distribution, the following chart appears. Observe that on the cell formula window and on the parameters section, you can view the 2 convoluted or compound elements of any given compound function, the frequency part and the severity part. 55. By clicking on the formula bar on either one of the 2 sub-functions placed here by default, the Poisson distribution for frequency and the log norm distribution for severity, you can alternatively evaluate the 2 elements that compound this distribution. 56. Click on the frequency Poisson segment of the formula and observe how the parameter is now ready to be edited. We will use this Poisson frequency distribution for counting the number of events. 57. By clicking on the Assign Excel References as Arguments button, change the single lambda parameter for the Poisson distribution by making a reference to cell D18. 58. Click on the icon on the upper right-hand corner of the small window to return to the Poisson chart, which should now look like this. We have now completed the first frequency part of this compound distribution. Let us complete the severity part. 59. Click on the severity part of the formula, the risk log norm section. The following chart appears. 60. Out of the function drop-down list on the parameters section, change the severity function to a PERT distribution. The following chart appears. 61. By clicking on the Assign Excel References as Arguments button, change the 3 PERT parameters for a minimum at cell G18, a most likely value at cell F18, and a maximum value at H18. 62. Click on the icon on the upper right-hand corner of the small window to return to the PERT chart, which should now look like this. 63. Now click on the risk compound section of the formula so that @risk can now generate 1,000 pre-iterations that would make look your Poisson PERT distribution compound function as follows. This is a convoluted, pre-simulated outcome of the risk weather-related delays. You can now close by clicking OK on your chart. The convoluted function should now look like this. Equals risk compound, open parenthesis, risk Poisson, open parenthesis, D18, close parenthesis, comma. Risk PERT, open parenthesis, G18, comma, F18, comma, H18, close two parentheses. As we have mentioned before, we call these types of risks as multiple frequency single type of events. In other words, an event may occur or not a number of times during a certain time period or project in this case, and for each one of these occurrences, a different severity magnitude occurs.